Okay, hello beautiful people, welcome to another lesson maths video. Today we are looking at a grade 11 topic, which is geometric progression, sequence and series. So I expect you to pay a particular attention because this is going to be awesome. Don't miss any second of this video because it is of great importance that you know how to solve geometric progression. So I would advise you to like, comment and share the video, and subscribe if you are not, so that you may benefit more from these examination topics. These are topics that they never miss in your grade 12 examination. If you know them in grade 11, you are assured that in grade 12 they will come in your examination paper. Now let's begin. Sequence and series, we are focusing on geometric progression, which is sometimes is called GP. GP is abbreviation of geometric progression. Now, lesson number 1 of geometric progression, we will focus mostly on finding what the common ratio, the important part of geometric progression, and that will be this lesson. So, what is a geometric progression? We need to know what a geometric progression is. Remember, arithmetic progression, we did look at it saying that it is a sequence that, of course, there is a constant value which is called the common difference that separates the two terms. That makes it to be an arithmetic progression, so that when I multiply, when I add the common difference, when I add the common difference to the next term, I'll be able to get the next term. That is how it is. But what about the geometric sequence? Geometric sequence, which is GP, is a sequence of numbers such that the quotient, here the quotient, you remember the quotient here, it is the ratio, such that the ratio between any two consecutive numbers, between two consecutive numbers is a constant. Now, this constant, this constant is a number. So we are simply saying that when you find the ratio, the ratio is supposed to be a fraction. If I say this is 1, this is 5, I find the ratio between these two to be 1 over 5 or 5 over 1. If I find the ratio of this, which is 5 over 1, the answer is a constant one. That is what they are talking about. So they are simply saying that is what a sequence geometric progression is about. We need to have a constant value when you do our working with in a ratio form. Now, each term is formed by multiplying. Each term is formed by what? Multiplying a constant, which of course you have found here. Multiply the constant value to the previous one. Then you get the next term. Remember, in arithmetic progression, we are adding the common difference, which is the constant, to the previous value to get the next term. Now, in geometric progression, we don't add, we multiply. The common ratio which we have found, the constant, we multiply it with the previous term to get the next term. That's what they are talking about. And then now they are simply saying again, this constant that we are talking about, it is called denoted by small letter r, and this constant, it is called the common ratio. This constant is called the common ratio. In arithmetic progression, it was called the common difference. Remember, common difference. But in geometric progression, it is called the common ratio. Okay, good. Now, how do I find the common ratio in geometric progression? Simple. This is how you find the common ratio. Common ratio, which is simply abbreviated, denoted by r, small letter r, is equal to term 2 divided by term 1, because here we are talking of the ratio. It's a common ratio, so you need to write it in a ratio form. Or you can say term 3 divided by term 2 or term 4 divided by term 3. You are going to find the common ratio, which is the constant. Or you can see preceding term divided by preceding term, meaning that the second term divided by the first term, you are going to get the common ratio. Okay, now let's look at the example. So this formula, please use it, remember it, so that you see, you don't forget. It's going to be usable, especially in questions that when you look at geometric mean. Okay, when you're talking of geometric mean, or maybe a complex geometric progression where we are given m plus 3, comma 2 plus z, comma 5 plus z. Find the value of z. These formulas are very important. Now let's look at the example. Okay, so here's the example. The example is after you have known the formula. Now let's see if we apply this formula to get the answer. The following sequences are geometric progressions, GP. Okay, A 2 4 8. Okay, B 4 2 1 1 over 2 1 over 4. Meaning they continue. These are infinity geometric progressions. Now find the common ratio. Simple. So let us find the common ratio here. So I'm going to say solutions to find the common ratio. So we write the first sequence, geometric progression. Okay, we have 2, 4, 8, meaning they continue to go like that. So that is the sequence we have. That is the first sequence that we have. So we need to find the common ratio for this sequence. So how do we find the common ratio? By using the formula here. So we're simply saying common ratio in this one. So let us write it in full. Common ratio, which is abbreviated as R, is equal to T2 term 2 divided by term 1. Okay, so if you want, you can simply say term 3 divided by term 2. You still find the same answer. This answer and this, they are just one the same. So you just pick one. You don't use both of them. Just get one of this and use it. So let's use this one. What do we find? What is my term 2? This is term 1. You can see this is term 1. This is term 2. And this is term 3. So there are 3 terms that we know. The 3 consecutive terms we have here. So what is term 2? Term 2 it is 4. Divide by what is term 1? Term 1 it is 2. So what is my common ratio in this scenario? 2. So the common ratio is equal to 2. Simple for the first sequence. So what will be the common ratio? So now if you want to know that this is same, look at this one. If you want, you can use this one. You should find the answer correct. Look, what is term 3? It is 8. So you write 8 there over. Term 2 it is 4. And what is 4? It is 2. So you see, you just use one. Don't use all of them. Okay, don't do like this. Just use one. If you select, you say I'm going to use term 3 over term 2, quite alright, okay, fair. Term 2 over, you get your answer correct. Okay, so that is how you find the common ratio. So once you do that, then it means that you are done with that one. Now let's move on to B. B, what is my B? So B says that we need to find the common ratio for this one. So we have 4, 2, 1 over 2 and 1 over 4, comma, goes like that. So we need to find the common ratio for this one. Now, remember the common ratio, it is a number. Once it's a constant, when we have found it, we multiply it with the previous term, we get the next term. So if we say 2 times 2, we get 4. 4 times 2, we get 8. 8 times 2, we get 16. Just like that until you find your answers. Same applies here. We multiply. We don't add. We multiply. Okay? If you are going to say add here, like you say 4, 2 plus 2, you get 4 quite right. But what is 4 plus 2? It is not 8. You see that? So this is a geometric progression. It's not arithmetic progression. Arithmetic we add, but geometric we multiply. So let's continue now. So common ratio for this one, we're saying common ratio is equal to, we're going to use any term we want. Which term? Well, let's say term 2 over term 1. So what is our answer here? Term 2 it is 2. Term 2 is 4. So what is my final answer? It will be 1 over 2. 1 over 2. Or you can say 0.5. 0.5, but I will not advise you to use decimals because this is of course, when it's in this format it is easy to use, but in this format it's not easy. But keep in mind this is a geometric progression, it's paper 2, hence a calculator you need to have. Okay, you need to have a calculator. I would advise you to get Casio. Casio is very good in terms of working. I trust it because I've been using it for years and years, and it has never given me problems. So get Casio and you are going to use it very effectively. This is the topic that you need to have a calculator, and it's paper 2. So use your calculator effectively to get a distinction in your mathematics. So that we have found the common difference, which is, the common ratio, which is 1/2, then this will be true by simply saying, if I multiply, let me say I multiply 4 multiplied by common ratio, which is 1/2. 4 multiplied by common ratio, which is 1/2. Am I going to get this term? Is it true? Let's see. When we multiply this, it will be 4. 4 times 1 is 4/2. 2 into 4, it is 2. Correct? So meaning that this common ratio, which we have found, it is 100% true. If you want, you can try it with any term. Multiply 1 with 1/2 and see if you are going to get 1/2. Let's try and see. 1 multiplied by 1/2. 1 times 1, it is 1/2. See? So here we multiply to get the answer. If you are going to add, you are not going to get the correct answer. So common ratio, we multiply a constant value to the previous one. The constant value, it is the common ratio. So this is how you work out the geometric progression, dear ones. Hopefully I've made this interesting and very easy for you. The next video we shall look at how to find the nth term of a geometric progression, and from there we shall proceed to finding the geometric mean and the sum. After finding the sum, we shall look at sum of infinity, and that will be the end of geometric progression. So you see, we have a lot to cover. Don't miss any lesson video, because if you miss this one, the next video will be difficult. I would advise you to make sure that you pause the video, copy the notes, and let it all be done. As for now, we shall meet in the next lesson, which will be, of course, looking at the nth term. God bless, and see you in the next video. Bye-bye.